All right, in this video, we're going to review graphs of linear functions. If you'll recall the slope-intercept form of an equation, remember that in slope-intercept form, the equation should be written as y equals. So you have y by itself on the left side of the equal sign, y equals, and on the right side of the equal sign, you have mx plus b. In the spot where the letter M is, that is your slope. So whatever number is in front of X, that number represents the slope. And then your B term, the term that you add or sometimes subtract after X, that's going to be your Y-intercept. Now, the Y-intercept, as an ordered pair, you always have X as your coordinate being 0. So whenever you're at the y-intercept, your x-coordinate will always be 0. And of course, the y-coordinate will be whatever b was, that y-intercept. Now let's look at some examples. In this first example, we're going to graph the line using the slope and the y-intercept. So first, let's look at this equation already in slope-intercept form because we have y by itself on the left side of the equal sign, and it equals 1/4 x minus 3. So remember that slope-intercept form we wrote as mx plus b on the right side of the equal sign, where m, the number that's in front of x, in this case is 1/4, is going to be your slope. And b, the term after x, is going to be your y-intercept. So minus 3 or negative 3 would be the y-intercept. And we would identify m and b as such. Our slope m is 1/4, our y-intercept is negative 3. The first step you want to take is you want to plot the y-intercept on your coordinate plane. So you will go to negative 3 on the y-axis and plot that point. Next, you would use the slope to find the second point. Remember, our slope is 1/4. Because it's a positive 1 in the numerator, we're going to move up 1 space. A positive 4 in the denominator, we're going to move to the right 4 spaces. So this is a P, that's up, and then right 4 spaces based on that number that's in our denominator. And then we'll connect these 2 points from step 1 and step 2 to make the line. So if we had our coordinate plane, here's our y-axis and our x-axis, we would plot our y-intercept. We would go to negative 3 on the y-axis. So here's your y-axis. We would go down 1, 2, 3. Here's negative 3. Plot the point. Now we're going to use the slope to find the second point. Up 1, right 4. So start at negative 3 on the y-axis. So we're going to go up 1 and then right 1, 2, 3, 4. So starting at negative 3, up 1, right 1, 2, 3, 4. Plot the second point, and then we'll connect these 2 points to create the graph. All right, let's look at the second example. If we're asked to graph this line using the slope and the y-intercept, notice we don't have y by itself on the left side of the equal sign. Therefore, we have to solve for y first. We need to get y by itself. So we're going to subtract 2x from both sides of the equation first. Minus 2x on the left, minus 2x on the right. That cancels the 2x on the left side of the equal sign, leaving 3y. And on the right side of the equal sign, we have negative 2x plus 12. Next, we're going to divide both sides of the equation by 3. Everything on the left side, everything on the right side by 3. So remember, you're dividing all 3 terms. So 3 divided by 3 on the left leaves y by itself. And on the right side, negative 2 divided by 3 gives us negative 2/3. 12 divided by 3 gives us 4. Now we can identify our slope, which is the number in front of x, negative 2/3, and our y-intercept b, which is 4. Now to graph this, we would plot our y-intercept first. Our y-intercept is 4. So on the y-axis, we're going to move to 4. Let's draw another coordinate plane here. We have x-axis, y-axis, and we're going to 4 on the y-axis. So we're going to go up 1, 2, 3, 4 spaces and plot the point. Next, we're going to use our slope to find a second point. This time our slope is negative. We got negative 2/3. That negative we're applying to the numerator. So that means we're going to go down 2 spaces, and 3 in the denominator tells us to move right 3 spaces. So starting at our y-intercept, we're going back to 4 on the y-axis. We're going to move down 2, right 3. 1, 2 down, and then right 1, 2, 3. So we went down 2, right 1, 2, 3, plot the point, and then we will connect those 2 points to create the graph of the line. All right, in example 3, we have a slope-intercept form of the equation that we're asked to write. When we're given a y-intercept of 0, -3, and a slope of 1, 4. So our slope, remember slope is our m term and the y-intercept is our b term. So we just need to substitute those values into the slope-intercept form of an equation. So using m equals 1/4 and b equals -3, we're going to write the equation in the form y equals mx plus b. So we're simply substituting the value for m and the value for b. Our equation should be y equals 1/4 x minus 3. Now, sometimes we will have a different form of an equation called the point-slope form. This is the point-slope form of an equation. Y minus y sub 1 equals m, and in parentheses x minus x sub 1. Now, just like in the slope-intercept form, the letter m stands for slope. So that number that's in front of the parentheses or in front of x is our slope. And then we have a point that's identified as x sub 1. Our x coordinate is x sub 1 and y sub 1. The y coordinate is y sub 1. So here where you see x sub 1 and y sub 1, that is the point that has been identified in point slope form. In this example, we're going to use the point slope form to write the equation of a line. So we have the slope, or m, as -3, and we have the point 1, -5. Remember, the point is identified as x sub 1, y sub 1. And we're going to write the equation in slope-intercept form. But because we were given a point and a slope from the beginning, we'll use point-slope form. Y minus y sub 1 equals m, and in parentheses, x minus x sub 1. Where, again, our slope is -3, so where m is, we plug in -3. And our ordered pair, x sub 1, y sub 1. Our x sub 1, we would plug in 1, and our y sub 1, we would substitute -5. And this is our equation. Y minus 1 equals -3, and in parentheses, x minus -5. Remember, a minus and a minus side by side is addition. So we would simplify this as y minus 1 equals -3, and in parentheses, x plus 5. Now let me go back to that last one. So we were asked to write this equation in slope-intercept form. So we actually wouldn't stop here. We would need to continue after we have that point-slope form of y minus 1 equals -3 times x plus 5. We need to get y by itself on the left side of the equation in order to write slope-intercept form. So we're going to add 1 to both sides of this equation. All right, so that will cancel our 1's on the left side, leaving y, and that's what we want. Now on the right side, we have a little bit more work to do. What you want to notice is outside the parentheses, you had -3. So that would be rewritten as -3x minus 15. And then that minus 15 plus 1, we can simplify those terms. So we just simply carry down the -3x, and -15 plus 1 gives us minus 14. So our final answer in slope-intercept form would be y equals -3x minus 14. Now we're going to find the equation when we have a slope of -4 and a point -2, 5. So remember, this is our x sub 1, y sub 1, using our point slope form. So we're going to substitute those values. Our slope, or our m term, is -4, and the point is -2, 5. All right. So we see here that our point for x and y, we substituted our y coordinate, which was 5, our x coordinate, which was -2, and our slope, which was -4. And we simplified here. So -4 times -2 gives us +8. Carry down your b and carry down the 5. Now this is another way that we could write our equation in slope-intercept form without using the point slope form like we did for the previous example. After you substitute the point and the slope into the slope-intercept form of an equation, you're going to solve for b, because that's what we're missing. We're missing the y-intercept. To get b by itself, or to solve for b, we need to get rid of this 8. So we're going to subtract 8 from both sides of the equation. The 8's will cancel. On the right side, leaving b equals, and on the left side, 5 minus 8 gives us -3. Now that we have b, we know that b equals -3, and we already had the slope from the directions. We're going to substitute our slope of -4 and our b term, which we just found is -3, into the slope-intercept form of the equation. So into the y equals mx plus b form. When we substitute those values, we get y equals, our m is -4, -4x, and then our b is -3. So -4x minus 3 is the answer. All right, now we're going to use the point slope form to write an equation of a line. And we have 2 points that are given to us, 4, 0, and -4, -5. Now, how we're going to write this equation, we first got to use our form, remembering that this f of x, that's the function form for slope-intercept. If we had y equals mx plus b, we could substitute f of x for y. Now, we're going to use those 2 ordered pairs that we were given to find the slope of the line. Our formula we use to find the slope of a line when we're given 2 points is we take the difference in the y values divided by the difference in the x values. So look at our 2 points here. We have 4, 0, -4, -5. That first point we would label as x sub 1, y sub 1. And that second point we would label as x sub 2, y sub 2. And then look at our formula. In the numerator, we have y sub 2 minus y sub 1. We just simply substitute the numbers. Our y sub 2 is -5, so in the numerator, -5, minus y sub 1, which is 0. In the denominator, x sub 2 minus x sub 1. Our x sub 2 is -4, minus our x sub 1, which is 4. And then we simplify. -5 minus 0 gives us -5. in the numerator. A negative 4 minus 4 gives us negative 8 in the denominator. Negative 5 divided by negative 8 is 5/8. So this is our slope. Now we're going to use that slope we just found, 5/8, and one of the points. We use the first point. It doesn't matter which point you choose. Now we're going to use those two to find the y-intercept. So using our slope-intercept form of the equation, y equals mx plus b, we're substituting our slope 5/8 and the point 4, 0. So substituting 0 for y and 4 for x. We'll simplify here. 5/8 times 4 gives us 28. And now we're just going to subtract 28 from both sides. We'll get b equals negative 28. Now we know the slope. Well, we were given the slope at the beginning, and now we know the y-intercept. So we would use those two values to write the equation of the line. Our slope m is 5/8. Our y-intercept is negative 28. Now we write our equation, substituting the m and the b. We'll get our function form, like we were saying at the beginning. We could substitute where the variable y is, we would substitute f of x. But the right side of the equation will remain the same. We're still going to substitute the value for m, 5/8, and the value for b, negative 28, on the right side. So we'll get f of x equals 5/8 x minus 28. Now, the reason we changed from y to f of x, because in our directions, we were told to write the equation using function notation. So that's what that means, to change from the slope-intercept form to functional form. We use f of x instead of y. All right, now we're going to use the graph to find values. Part A, we're going to find the equation of the line that's graphed. And then we're going to write that equation in standard form. Step 1, here's our graph. See this blue line in the bottom right-hand corner. You want to find the y-intercept, or b. So you want to know where that graph crosses the y-axis. We would simply go to our graph right here. See where we touch the y-axis? That's our y-intercept. Now we estimate it to be about 4.25. Not quite in the middle, not halfway between 4 and 5, a little bit lower. So 4.25. That's our y-intercept. Step 2, we're going to pick 2 points and find the slope. It doesn't matter which 2 points we pick. We could pick a point here. And make sure you pick a point where we cross between the lines. That'll make your counting easier. See where I cross these intersections right here in the corners. And we want to measure the distance that it takes for us to get from one point to the other. So if I start with this point here in the bottom left hand, I would move up 1 and write 1, 2, 3 to touch the second point. So this was the first point I used. This is the second point. To get from point 1 to point 2, I go up 1, right 1, 2, 3. So my slope, since I had to move up 1, is positive 1 in the numerator, and to the right 3 spaces is positive 3 in the denominator. So this is our slope. Next, we're going to use that y-intercept we just found, 4.25, and the slope, 1/3, to write the equation. So it will be written as y equals 1/3 x plus 4.25. Now, the second part asks us to find the value of the function when x, remember this was f of x, meaning that term that's in parentheses is our x. What is the value of this function when x is negative 1? Let's just look at our graph. When we're at our graph, right, when we're on the x-axis right here at negative 1, where does our graph touch? That point intersects right there at we're at 1, 2, 3, 4. So you can also substitute -1 for x and solve using the equation that we found in step 3. So where x is, we would just substitute -1. We'll get f of -1 equals 1/3 times -1 plus 4.25. And when we simplify, we'll get 3.92. So that looks very close to what we have. Let me erase some of this so we could see how at that point, when we're at -1, we don't quite cross exactly at 4. We're really close to 4. So 3.9 sounds about right. 3.92 is the value of the function when x is -1. Now part C, find x such that f of x equals 5. So now we're given the value of the function, and we want to know what the x coordinate is when the function is at 5. So we would substitute 5 for y in our equation. So we have 5 for y on the left side of the equation equals 1/3 x plus 4.25. We would simplify. We're going to subtract 4.25 from both sides of the equation first. And when we do that, we'll get 0.75 equals 1/3 x. Next, we're going to multiply both sides by 3, and that gives us our answer. The x is 2.25. 3 times 0.75 gives us 2.25. And that's our answer. All right, example 7, we're going to write the equations of the vertical and horizontal lines. Now, this word vertical means line that goes up and down. Horizontal, line that goes left to right. If we're given this ordered pair of 2, 3, remember this is our x coordinate, this is our y coordinate, so this is where the graph cuts through the x-axis. So imagine that. The graph cuts through the x-axis at 2, so it has to be a vertical line. It has to go up and down in order to cut through the x-axis. And the graph cuts through the y-axis at 3. So if I'm at 3 on the y-axis, I'm here. In order for me to go through the y-axis, it would have to be a horizontal line. So we should see horizontal line, y equals 3. We should see vertical line at x equals 2. All right, find the equation of the parallel and perpendicular lines. Now, we're going to find the equation of the line that contains this point 4, 4, and is parallel to the line 2x plus 3y equals -6. First of all, we need to remember that parallel lines have equal slopes. So their slopes are equivalent. We just need to find the slope of the given line. How do we find the slope of the given line? We're going to solve for y. We get y by itself on the left side of the equal sign. So first we're going to subtract 2x from both sides of the equation. So we subtract 2x from the left side, subtract 2x from the right side. The 2x's will cancel on the left, leaving 3y equals, and on the right side of the equal sign, -2x minus 6. Then we're going to divide both sides of the equation by 3. So the 3's will cancel on the left side, leaving y. And on the right side, we have -2/3 x. Minus 6 divided by 3 gives us -2. So here's our slope. Remember, the number that's in front of x is -2/3. So now we have our slope. And we're going to substitute the ordered pair, the point that we were given 4, 4, to find the y-intercept. So using our slope-intercept form of an equation, we're substituting 4 for x 4 for y, that's our ordered pair. So 4 for y, 4 for x, and our slope, which was 2/3 for m. Simplifying here, negative 2/3 times 4 gives us negative 8/3. And now we're going to add that 8/3 to both sides of the equation. And we'll get b equals 20/3. After you get your y-intercept, you can write the equation. We know b is 20/3 and we know our slope is negative 2/3. So the equation would be y equals negative 2/3 x plus 20/3. Here's another example. We're going to find the equation of the line that contains the same point, 4, 4, and is perpendicular this time to the line 2x plus 3y equals negative 6. So unlike parallel lines, perpendicular lines have slopes that are opposite reciprocals of each other. So their signs are opposite and they're reciprocals of each other, meaning you can flip the fraction form of one to get the other. So slopes are opposite reciprocals. We're using this equation that we were given, 2x plus 3y equals negative 6, to find the slope. In order to find the slope, we're going to solve for y. Just like we did before, we're going to subtract the 2x from both sides of the equation. And when we do that, we'll get 3y equals negative 2x minus 6. And then we're going to divide 3 from both sides of the equation. So we're dividing 3 on both sides, and that's how we get y by itself on the left equals negative 2/3 x minus 2. Negative 2/3 is our slope. But the opposite reciprocal of negative 2/3. So negative 2/3, opposite negative would be positive, and the reciprocal we get when we flip this fraction. We move the denominator to the numerator and the numerator to the denominator. That's how we get positive 3/2. So this is our slope. Now we're going to substitute the point 4, 4 and the slope we just found, 3/2, to find the y-intercept. So using our slope-intercept form of the equation, we're substituting 4 for x, 4 for y, and 3/2 for m. 3/2 times 4 gives us 12/2. Carry down the 4, carry down the b. Now we could simplify here because 12/2 is the same thing as 6. And we subtract 6 from both sides of the equation. On the left side, 4 minus the 6 gives us negative 2. Now that we have the y-intercept, b, and we have that slope, we can write the equation. Substituting into our slope-intercept form, we'll get y equals 3/2 x minus 2. Now you try one. We have the equation of the line containing this point, 3/4, and we want to write the equation of the line that's perpendicular to 2x plus 4y equals 5. So take a moment to try this one. All right, your first step, you want to use this equation to find the slope. So we got to solve for y. Subtract 2x from both sides of the equation. Divide both sides of the equation by 4. And you'll get the slope as negative 1/2, right? When we simplify this negative 2/4, we'll get negative 1/2. But because we're looking for the perpendicular slope, remember you take the opposite reciprocal. So you flip this fraction and you change the sign from negative to positive. 1/2, when we flip, we get 2/1, and 2/1 is just 2. So our slope is 2. Now we need to find the y-intercept. You substitute 2 for your slope and use the point you were given, 3, 4, to find the y-intercept. When we substitute those values into our slope-intercept form of the equation, using 3 for x and 4 for y, we'll get y equals 2 times 3 plus b. 2 times 3 is just 6. We're going to subtract that 6 from both sides of the equation. We'll get our y-intercept. B is -2. Now we can write the equation. Use your b, use your slope, which we found as being 2, to write the equation. So our equation would be y equals 2x minus 2. And that concludes our notes.